Welcome to our training on Zero Code Analytics. This initiative is led by AFRO's Agri-Food Working Group, the African Federation of Operations Research. The Agri-Food Working Group promotes research in agri-food supply chains in Africa for improved data-driven decision-making and enhanced food security. The goal is to support academics and professionals of logistics and supply chain fields. I'm Ali, a researcher of operations research. In this session, we discuss predictive models for quantitative variables. First, we will discuss the few models used. Second, we will discuss the methods used. Third, we will see the workflow created in Orange. And finally, we will see and discuss model parameters and see the final results. We will use linear regression, random forest, and neural network prediction models. Images taken here from these references will be explained in the following slides. For linear regression, we take X independent variables and Y predicted dependent variable and try to fit line through the data with least discrepancy. We can see in the image the line drawn to create least error, which can help us in making predictions. Second, random forest generates predictions based on trees and branches, averaging the final result of each tree in the forest to provide a final quantitative prediction. Neural network models, we predict using a hidden layer of coefficients that help generate the best prediction. This is done through many nodes. We do this through the machine learning cycle of splitting data into training and validation data sets. Training data results in a model with particular setup to solve the problem at hand. The model can then be used to validate the problem solution using test data. This is what the model will look like in Orange. You don't have to use all methods, but functionality of Orange makes this a breeze. First, we open the data through a file import. We view the data in a table and select the required columns for our experiments. That we use data sampler to split the data and connect it to our training model. The model resulting is calculated and saved in the test score, which gets the data and provide model effectiveness. The prediction node below saves the model's results and shows each test set solution comparison of all the three training models. We will see this in the following slides. For each training model, there is a hyperparameter that influences the score of each. For linear regression, mainly there are regularization, which falls between 0 and 1. We set it at 0.5 for the target results. For random forest, we can control the number of trees. For neural networks, the neurons, the hidden layer, activation, and solver can be changed. This is the final setup that provided the best solution for our problem. The model scored best is neural network with random forest and linear regression falling at second and third. The results are similar to that of linear regression. The high margin standard error, the lower the model performed, and the higher that of residual R2, the better the model performed. Here we can see that neural network has scored the best. There is a neat node in Orange called the score node. It will compare each model results with the testing sample. We can see here how each model prediction deviated from that of the training sample. Thank you for choosing to learn with us. Stay tuned for more zero-code supply chain analytics.